Hi everyone, I'm Vered Schwartz from Bar-Ilan University, and I'm presenting this work about paraphrasing noun compounds. This is a joint work with my advisor, Dodagan. So let's start by defining what I mean by noun compounds. So these are sequences of two or more words with a head noun that form some kind of a new concept like hot dog bun package, and so on. And specifically in this work, as in a lot of previous work, we focused on two words, noun compounds. So noun compounds express this implicit semantic relation between the constituent nouns. For example, an apple cake is a cake made of apples, while a birthday cake is a cake eaten on a birthday. So these are two similar, the same head, different modifiers and different semantic relations. And this nice definition from Nakov defined noun compounds as text compression devices that allow us to say more by using less words. And the nice thing about it is that we're actually pretty good at decompressing them. So let's see an example. So we are good at interpreting noun compounds, even if we've never heard them before. So I guess most of you have never heard about parsley cake. So we could think about a lot of different interpretations for that. It could be a cake eaten on a parsley, cake with parsley, cake for parsley, and many other options. And it's quite trivial in this case. Even if we've never seen this noun compound before, we quite easily interpret that as cake with parsley. And if you attended the tutorial on Sunday from Emily Bender's tutorial, then there was also an example of, I think it was a crocodile burger, so it's pretty much the same. So how can we do that? So one way to do that is by generalizing our existing knowledge about things in the world. So we can ask ourselves, what can cake be made of? And here's a screenshot from a corpus search of cake with something. And I don't know if you can read that, but it says cake with chocolate, lemon, strawberries, candles, caramel, frosting, vanilla, berries, and so on. So a lot of the words in this distribution are food-related, and many of them specifically are fruit. So we can say that parsley sort of fits into this distribution, or at least it probably fits better than it does to the distribution of cake eaten on a something. So this is similar to selectional preferences. So we are good at doing that. We also need computers to be able to do that. I don't think I need to convince you. So here's an example for actually a successful interpretation. I asked the Google Assistant to create a morning meeting, and it interpreted that as creating a new event in my calendar whose time is the next day in the morning. But that's a rather easy noun compound because morning is almost always a time modifier, but of course we could think about more ambiguous and complex examples. So there are many noun compound interpretation tasks, starting from bracketing. So if you have more than two words, you need to know how to, what's the relation between which words are the heads and which are their modifiers. So for example, you would want to know that it's pumpkin spice latte and not pumpkin spice latte. Compositionality prediction, so to what extent is the meaning of the compound derived from the meaning of its constituents. So for example, spelling bee is non-compositional because it's not related to bees. And with respect to the implicit semantic relation between the nouns, so there's the relation classification task in which noun compounds are classified to one relation out of a predefined set of a predefined ontological relations, so something like classifying apple cake to ingredient and birthday cake to time. And the more free form of that is the paraphrasing task, in which we need to explicate this relation by paraphrasing it, so saying cake made of apples and cake eaten on a birthday. And this is the task that we focus on in this work. In the paper, we also have evaluation on relation classification and discussion about compositionality, but I'm not going to talk about it here. So the paraphrasing task, the motivation for the paraphrasing task comes from the fact that you can paraphrase the noun compound and express the semantic relation between the nouns explicitly. And then you can have multiple prepositional and verbal paraphrases. For example, an olive oil is oil extracted from olives, made of olives, and from olives, and so on. And then you could also think about these paraphrases as templated paraphrases with W1 and W2 for the constituent nouns. In practice, our evaluation setting is a bit different. We worked with the only available dataset for this task, which is the SemEval 2013 Task 4. And rather than being defined as a retrieval task, like I just defined it, it's actually a ranking task. So what happens in this task is that systems get a list of noun-compounds, and they have to extract paraphrases for each compound from free text, from a corpus, and they have to rank them. And then they are evaluated for correlation with human judgments. And the gold paraphrase score was determined by the number of annotators that suggested each paraphrase. Prior methods for this task are usually based on the concurrences of the constituents in a corpus. So for example, for apple cake, you might expect to find a paraphrase like a cake made of apples that appears in the corpus. This is problematic for two related reasons. So first of all, many noun compounds don't have any paraphrases in the corpus. So it could either be because they're very rare, like parsley cake, or maybe the other way around because they're very highly lexicalized. They always appear as a compound, they never appear explicated, like ice cream. And on the other hand, you may have some compounds that do have paraphrases in the corpus, but they just have very few paraphrases. And we would want our model to be able to extract more semantically related paraphrases. So for example, if we observe cake made of apple, we would like our model to infer that it's also cake containing apple. So prior work provides partial solutions to either one of these problems, but not to both of them. So the melody system from the original participants addressed the first problem. So what they did is to represent a noun compound with a compositional distributional representation. That basically means that you have some function f that you learn over the, you apply to the distributional representations of the constituents. So for example, the vector of apple and the vector of cake. And then you get a noun, vector representing the noun compound apple cake. And they use this vector to classify, they predict existing templated paraphrases in the corpus. And the outcome of this is that if now they get, during test time, an unobserved noun compound like pear tart, it would be potentially embedded in proximity to apple cake and then yielding the same paraphrases. With respect to the second problem, the solution is a bit weaker. So the IIITH system, again from the SemEval participants, they learned easier relationship between paraphrases. So if a subset of the noun compounds that appeared with W2 made of W1 also appeared with W2 extracted from W1, then they learned that the latter is a type of the former. And our solution was multitask learning to address both problems. So in our multitask reformulation, this is what a training example looks like. It consists of three components. The W1 is in apple, W2 is in cake, and the paraphrase, W2 made of W1. If we have more than one paraphrase for a noun compound, then we just split them into multiple training examples. And our main subtask is to predict the paraphrase P given the noun compound W1, W2. So it's essentially answering the question, what's the relation between apple and cake? We also have two helper tasks. So the first one is to predict W1 given the paraphrase P and W2, which is like answering the question, what can cake be made of? And similarly, we also try to predict W2 given the paraphrase P and W1, which is like answering what can be made of apples. This is what the main task looks like. So our paraphrases always start with a placeholder W2. This just happened empirically, but it's probably because W2 is usually the head noun. So it's usually head noun dot something modifier noun. And so what we do here is we encode this missing paraphrase of W2, paraphrase W1. In this case, it's going to be cake, placeholder P, apple. And we use a BILSTM to encode it. And then we take the output vector of the input of the placeholder, and we feed that into an MLP that tries to predict an index in the paraphrase vocabulary. So similarly to the melody system, we also don't generate any new paraphrases in this work. We just try to predict templates of paraphrases that appeared in the corpus. but not necessarily with this specific noun compound. So the green vectors are fixed word embeddings, specifically 100-dimensional glove embeddings, and the orange ones are learned placeholder embeddings for the three components. And similarly to the melody systems, we also generalize for semantically similar unobserved noun compounds. So again, if we now see paired out during test and we haven't observed that during training, or we don't have any paraphrases for that, it's expected to yield similar results to apple cake. This is one of the helper tasks. The other one is similar. So here we try to predict W1, answering what can cake be made of. So again, we encode our missing paraphrase. In this case, it's cake made of W1. We use the same BiLSTM and the same embeddings to encode it. And we take the output vector of W1 and feed it into a different MLP that tries to predict an index in the word vocabulary. And the two helper tasks help us embedding semantically similar paraphrases in proximity. So paraphrases could be similar either due to lexical similarity, as in W2 made of W1 and W2 is made of W1, which would naturally be encoded in proximity, but also because they just appear with the same noun compounds. So this helps encoding them in proximity. Similarly to previous work, we collected data from Google Ngrams, and our model is semi-supervised. It starts with a set of noun compounds, not just the ones from the semi-val dataset, because it's rather small. So we also enhanced it with another classification dataset. And we only use the training data to extract templates of plausible part-of-speech tags, as in verb preposition W2, verb preposition W1, to reduce the search space. We also assign weights for each training example. The natural way would be to assign a weight based on frequency of the Google Ngrams corpus. But what happens in this case, and it was also pointed out in previous work, is that it rewards the more common propositional short paraphrases. So to avoid that, we just normalize the weight separately for each length of paraphrase. And we end up with this number of instances. As I said before, our evaluation is on a ranking task, so we also have a ranking component. We start with predicting the top K paraphrases for each noun compound, and then we learn to re-rank them to better correlate with human judgments. So our ranking model is an SVM pairwise model. It's basically a binary classifier for each noun compound, and for each two paraphrases, it has to determine whether the first or the second paraphrase should be ranked higher. And it's based on shallow features like part-of-speech tags, prepositions, length, and the input from the original model. So the semi-val task provided an evaluation script. It's not some kind of a standard evaluation metric. And they have two evaluation settings, isomorphic and non-isomorphic. And we compare with the three semi-val participants and the baseline. So the isomorphic setting is the more challenging one. It expects the system to produce as many of the paraphrases as possible and pretty much in the same order. So essentially, it rewards both recall and precision. And in this setting, we outperform all the baselines. The non-isomorphic setting is the more relaxed setting. It expects the systems to produce only the top-ranked paraphrases, and it doesn't care about the order. So basically, it's like it rewards only precision. So what happens here is that we outperform the two other baselines that perform well in the isomorphic setting. But there are two other models. One of them is the semi-val baseline, which are rather conservative models. They tend to predict only a few very common paraphrases, so they don't make a lot of mistakes. So it's hard to beat them on this setting, but it's also not very informative. For example, the semi-val baseline always predicts only prepositional paraphrases and always in some kind of arbitrary fixed order, like always starts with W2 of W1, W2 from W1, and so on. So it's not a very informative setting. Okay, so we did some error analysis, starting with the false positive paraphrases. So these are paraphrases that our model predicted, but were not in the gold standard. 44% of them were actually valid, just missing from the gold standard. It's pretty reasonable because it's not exhaustive. We also had 15% of paraphrases that were too specific. So, for example, for community life, a model should have predicted life in community, but has predicted life of women in community. We also had 14% of incorrect prepositions. So this happens, we first assume that this happens because prepositional paraphrases are very common, so the model just defaults to always predicting them. But then looking deeper into the data, we saw that the problem actually starts in the training data. So what we conjecture is that the Google Ngrams corpus, since it doesn't respect the syntactic structure of a sentence, then you can get from a sentence like rinse away the oil from baby's head, you can get an Ngram like oil from baby, which is definitely not a good training example. So that's a problem. We also had syntactic errors and 5% of borderline grammatical paraphrases. These are paraphrases that are not completely incorrect, but they just don't sound very well, like force of coalition forces. With respect to false negatives, we had 30% of paraphrases that were just too long. Unfortunately, since we used the Google Ngrams corpus, we were constrained to up to 5 words, and many of them were longer than that. We also conflated similar paraphrases before training by removing determiners and adjectives, but then 25% of the test paraphrases contained determiners. And some inflected constituents, 10%. So, for example, for shareholding, we predicted holding of shares, and holding of share, and the gold standard said holding of shares. So to recap, I presented a model for generating paraphrases for given noun compounds that explicate the semantic relation between the constituents. It has better generalization abilities, both with respect to predicting the same paraphrases for similar unobserved noun compounds, and with respect to embedding semantically similar paraphrases in proximity and predicting more semantically similar paraphrases. And we have improved performance in challenging evaluation settings. Thank you.
Okay, we have plenty. Thank you very much. We have plenty of time for questions.
Hey, thank you for your talk, and it's very interesting. I have 2 questions. Can you hear me clearly?
Yes.
Yeah, cool. So the first one is about, so you were saying your results is not able to compose like a plausible English phrases because you don't have determiners most of the time because you are doing classification tasks. I was wondering if you can do some post-processing like running a language model on top of the results, then probably it's going to help your results. Do you think so?
Definitely. This is not an inherent problem. It was just a bad design choice.
Yeah.
Well, we should have not removed the determiners before training or do some kind of post-processing, but it's not a real problem.
Yeah. Okay, so the second one is about, so you were so in your case, actually all the words will be appeared in the paraphrases word, right? So I can think of some very extreme examples like Air Canada. It's a phrase, and then air actually means airline. And then...
Definitely. So yes, we have I'm not even sure it's the same thing, but this is the proper name, the example you gave, but we also have a discussion in the paper about compositionality. And apparently, this model really assumes, it kind of makes sense, but the model assumes that the noun compound is compositional, which is by definition, you can explicate it by paraphrasing. And we actually try to check if it can handle non-compositional compounds or something that is not exactly the sum of its parts. And it's not good in that. You have to first determine that the noun compound is compositional, and then you can explicate that. But if it's not, then just an example at the top of my head, we tried checking what the model says about monkey business, and it just predicted that it's a business that sells monkeys.
I see. So I mean, in the original Word2Vec paper, they use some very simple co-occurrence statistics to calculate, to find those phrases, and then to train distributional vectors for those phrases. I was wondering if this kind of co-occurrence statistic will help your model.
It could help, yes. There are a lot of methods about that try to represent noun compounds as vectors, and I think it's probably complementary to this work.
Oh, yeah.
Yeah, it would be interesting to try to combine them.
Yeah, well, thank you.
Thank you.
Any more questions?
Thanks.
Going back to the question that the Air Canada example, let me give another kind of example that I think it's even more interesting to think about in this context, is something like National Research Council, right? So
Like
these
what,
are
sorry?
a quote's proper name, like National Research Council, and many of these others. Many government organizations have this sort of structure, which is compositional in some sense.
Yes.
Do you have any thoughts of how one might extend kind of your approach to these kinds of examples, which are not quite easy to paraphrase, but they have a very regular structure?
Yeah, I don't have a good idea about that. Yeah, but I thought about it because compositionality is definitely not a binary thing. So a lot of things could be, they are somewhat compositional, could be somehow rephrased, but not necessarily specifically in these constrained templates of part of speech tags and with the constituent nouns. I hope to have a good idea in the future for that, but don't have a good answer for that now.
Okay, so there are no more questions. We will thank the speaker again. Thank you.